Hello everyone, this is Brady. I'm currently still grading the assignment 1. I haven't completed all the grading work, but based on the outcome, I find out some common problems. So that's why I decided to provide the answers for some selected questions. The questions I'm going to pick are 2C, 4A, and 5A and 5B. Because particularly for question 5, many people seems to have a problem with the technique, like a proof by contradictions. So I decided to answer this question. Okay, so here's the question 2. So question 2 is about the truth table. Okay, construct a truth table for each of the following logic expression. I pick C. So in this case, in order to build the truth table, you first need to figure out what are the input values, and then choose all the possible values for each input variables. Okay, and then build a table from there. So in this particular case, there are 3 input variables: P, Q, and R, right? So then we want to build a table, the truth table. And first we pick all the possible combinations of P, Q, and R. So for each variable P, Q, or R, there are only 2 values, 0 or 1. So for all the combinations, you can find out, first possibility is that all the values are 0, and then you have 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. So there are a total of 8 possibilities. So the truth table we're going to build is based on these 8 values. So now the first one we want to figure out is the P implies R, because that's something in the left side. And then we're also going to build the Q implies R. That's the second one. And so then P implies R and Q implies R. So that's the whole left side. And we can also try to build a value for P or Q. And then P or Q implies R. So once we got this, and once we got this expression, then we can actually build the final values for the expression. So that's P implies R, and Q implies R, and P or Q implies R. So that's the final result. So let's see, P implies R. So we need to actually know what's the truth table for the implication, right? So for the implication, P implies R. So if both P and R are 0, so the result is going to be 1. Actually, if P is 0, then it doesn't matter what's the value of R. The result is always 1. The only chance that when you get a 0 is when P is 1, R is 0, right? So here, P implies R. P is 1, R is 0. So this is going to give you 0. P is 1, R is 1, that's 1. P is 0, 1, R is 0, that's give you 0. P is 1, R is 1, that'll give you 1. Okay. Now Q implies R, so that means all the result as going to be 1 as far as q is 0. So in this case, this will give you 1. You don't need to even think about what's the value of r. Now, so this one, q is 0, q is 1, r is 0, this give you 0. Q is 1, r is 1, give you 1. This one give you 0, this one 1, 1, give you 1. Okay. So then we're going to actually figure out the AND operation. So we already got a P implies R, Q implies R, and then you have an AND operation. So you just need to look at the values between here and here. So 1 and N, 1 and a 1, that's 1, 1 and a 1, that's 1, 1 and a 0, that's 0, 1 and 1, that's 1, 0 and a 1, that's 0, 1, 1, that's 1, 0, 0, that's 0, 1, 1, that's 1. Okay. And a P or Q. So the value going to be 0 only when both P and Q are 0, right? So in this case, you're going to get to 0. And then the rest of case, either P is 1 or Q is 1. So you got a 1, 1, 1, 1, 1, 1. Pretty simple, right? So now P or Q implies R. So if P or Q is 0, then the result can be 1. Remember the definition of the implication, right? As far as the left part is 1, 0, then it doesn't matter what's the outcome. Now, if P or Q is 1, so now you need to look at the R. If R is 1, then it's 1. R is 0, it's going to give you 0. So now let's take a look at the R. So R is 1 here, so this is a 1. R is 1 here, this is a 1. And R is 1 here, so this is a 1. And the rest of these are all 0. Okay. So now let's look at the implication for the final one. So this is a 1, 1, so you got a 1, 1, 1, you got a 1, 0, 0, you got a 1, 1, 1, you got a 1, 0, 0, you got a 1, 1, 1, you got a 1, 0, 0, you got a 1, 0, 0, 1, 1, you got a 1. Okay, so the result is going to be 1. Okay, so that means this expression is always true. Okay, so that's question 2. So, okay, let's take a look at the next question, 4a. Now, before we actually work on 4a, then we need to know the rule of precedence. So, the rule of precedence is that negation is always has higher priority, and then followed by the disjunction, and then followed by the followed by conjunction, and then followed by disjunction. So if you have operation like this, you can also evaluate negation of x, and then you have conjunction and disjunction. So always evaluate the conjunction first. Okay, so you're going to evaluate it like this. So you want to create a truth table and prove that the left side is equivalent to the right side. So there are 2 variables, x and y, so relatively easy to create this table. It's kind of easy to create this table. There are 2 variables. So the total number, the combinations are 4, right? So you have x equals 0, y equals 0, 0, 1, 1, 0, 1, 1. Okay, a very small table. So the first one we need to evaluate is negation of x. So negation of x is just opposite of value x. So if x is 0, negation of x is 1. 0, got a 1. 1, got a 0. 1, got a 0. Okay? And then you figure out what's the negation x conjunction y. So negation x conjunction y. So 0 or 1 0, you got a 0. 1 1, you got a 1. 0 0, you got a 0. 1 0, you got a 0. That's by the definition of conjunction. So the left side is x or negation of x, y. So you talk about x and this expression, negation of x conjunction y. That's all. So it's a 0 or 0, that's 0. 0 or 1, that's 1. 1 or 0, that's 1. 1 or 0, that's 1. So that's the left side. The right side is very simple. It's x and y. So x is 0, y is 0. So x or y is 0. X is 0, y is 1. X or y is 1. 1, 1, right? So when you talk about this disjunction or operation, as far as one of the operand is 1, then the result is 1. The only chance that you get 0 is both operands are 0. So now you compare the left expression and the right expression. You will get basically the same values. So then you basically proved that this is equivalent. These two expressions are equivalent using the truth table. Okay, let's take a look at the problem 5a. So it's actually the same, it's the same expression, but we try to prove by contradiction, not using the truth table. We just want to show that the left side is equivalent to the right side. But this time we try to use the contradiction. Now the idea of proving by contradiction is, we want to prove this is true, right? So let's say you're going to evaluate the negation first, then evaluate the conjunction. Okay. Now we want to prove that the left side is equivalent to the right side. So that means for any value x and y, any values x and y, the left side is always the same as the right side. Now to prove by contradiction, we prove that using the truth table, right? But to prove by contradiction, we just assume, okay, that this is not true, okay? Assume is not true. Now, if this is not true, that means then it means that either the left side is 1 and the right side is 0, or the left side is 0 or right side is 1. Okay, so these are the only two possibilities. So we need to prove that either case is not possible. So that's why if we prove one side, say assume that the left side is 0 and the right side is 1. Okay. We know it's not true, but we have to prove that this is not possible. Now, to prove this is not possible, then we should actually conclude that if we assume, the left side is 0 and right side is 0, we will get contradiction. So now, because we assume that the left side is 0, then we have x or negation of x conjunction y is 0, then we know that this leads to the conclusion that the x must be 0, and the negation of x conjunction y must be 0. Now why this? Because this is based on the truth table of the disjunction, the OR operation. Okay, or this is based on the definition of OR operation. Why? Because based on the OR operation, if this is 0, that means both x and also this must be 0. Because if one side is 1, then the OR operation will get you 1. So if this is a 1, the OR operation will get you 1. So if this is 0, then if and only if x equals 0 on the right side, negation of x conjunction y is 0. Okay. Now, I call this 1. This is 2. Now, and then from 1, x is 0. So we know that the negation of x must be 1, right? Negation of x must be 1. So if negation of x must be 1, then we try to figure out this one. So negation of x is 1. So negation of x and y. So negation of x is 1. So I replace negation of x with 1 and y. So based on the identity, some Boolean identity. So this is the same as y, right? Because it doesn't matter what's the value of y. So if y is 0, 1 and the 0 get you 0. Y is 1, 1 and the 1 get you 1. So this is always the same value as y. Okay. So, but we know that by assumption, this is 0, right? So that means y must be 0. So we get, if we assume this is the case, okay, we assume this is the case, then we will get x equals 0 and y equals 0. What does that mean? If x equals 0, y equals 0, that means x or y must be 0, right? Because x is 0, y is 0, then this is 0. Now what's the problem? This is contradictory to the assumption that the x or y is 1, because we assume that if this is if this is not true, then we assume that the one case is that the left side is 0, right side is 1, and then based on this we get x equals 0, y is 0. Because x is 0, x equals 0, y equals 0, then x or y equals 0. This is now these two, they contradict, they contradict to each other. So we proved. Now, to the assumption that x or y equals 1. So we're not done yet, because we only prove the one side. We also need to prove, because in order to prove that this is not true, this is not true, then we prove that it's not possible that the left side is 0 and the y side is 1. But we also need to prove that if we assume the left side is 1 and the right side is 0, this is also not possible. Okay. Then now if we assume this is the case, now we should get the contradiction as well, right? But this is also very simple.
Why? Because of this assumption, then because x or y equals 0, that means x must be 0 and y must be 0. Why? Because of the definition of the OR operation, right? This is a OR operation. So the only chance that the x or y equals 0 is x equals 0 and y equals 0. Now, if x is 0 and y is 0, then what you get? So that means x conjunction, oh, no, it's disjunction, negation of x or y. So we already know x is 0, negation of 0, y is 0, okay? So now that by the rule of precedence, you need to evaluate this one first, right? So you got negation of 0 is 1, 0. And then we need to evaluate this first, because that's the end always has a high priority than OR. So 1 and 0, this gives you 0. And 0 or 0, that's 0. And then we got x or negation of x and the y is 0, right? Now, what's the problem? Yes, because we assume that this is 1, but now we got this is 0. Again, we prove this by contradiction. So we prove that the either case is not possible. I hope this gave you some kind of explanation of the 5a. Okay, so let's prove 5b. And I just want to prove just one side, okay? So again, you want to prove that this expression and this expression, these two expressions are equivalent, okay? Now, using the proof by contradiction, then we assume, okay, A or B and A or C is, okay, let's say this is 0, okay? Let's say 1, okay? And the right side, A or B and C is 0. So we assume that the left side is not the same as the right side, right? Because we know that's not possible, but we have to prove it. Because we want to prove this is the case. So we assume that the left side is 1 and right side is 0, and hopefully we get a contradiction. Okay. Now, because of the assumption, so you got A or B and C equals 0. Now, based on the precedence of the operations, then you're going to evaluate the and before the or. So so this, you can put the parenthesis over here. It's the same as this because you always evaluate this first. So A or B and C is 0, then you will get A equals 0 and B and C equals 0, right? By the definition of disjunction. Okay. Now, so if A is 0, then let's take a look at the other one. Okay. We hope that we can get something which is contradictory to the assumption. So because we know A is 0, right? So then we know that let's try to evaluate this one. A or B. So then A is 0, so it's a 0 or B, right? Now 0 or B by definition, so it's the same as B. You can verify this very easily because that's an or. So because this is 0, so if B is 0, then you got a 0. So if B is 1, you got a 1. So this one has the same value as B. Same thing with A or C, right? So it's a 0 or C, so it's the same as C. So that basically means A or B and A or C is the same as B and C, right? Now, do you see the contradiction here? Because we know, based on this assumption, we got the B and the C equals 0. So this is actually 0. So B and the C is 0. Now, what does that mean? So that means A or B and the A or C is 0. So this is a contradictory to the assumption that to the assumption that A. So on one side we got this, which is 0. On the other side, by assumption, this is 1. So these two contradict to each other. So we proved that if we assume the left side is 1, right side is 1, then we got a contradiction. So I'm not going to actually prove the other side, because we also need to prove the other side. Assume that if this side is 0 and this side is 1, and we also get the contradiction. Okay, so then we can prove the whole thing.